Thank you. Thank you all for applauding. Yeah, my name is Corvin Schapöhler. I'm from Novatec, work there as a software engineer. And who here uses or used Kubernetes and thinks simple, easy to go, no problem there? Well, some people, some from Novatec who I will have to discuss later on if that's true. I think Kubernetes is a really nice and really good platform, but it's overloaded with a lot of stuff, and you have to keep a lot of things in mind. And to reduce this complexity and to make it more simple, there are a lot of tools. And we have a lot of tools already deployed and working. Everyone tries to make it more simple using a lot of tools, but how do we deploy them? How do we manage all of these tools? For this, the concept of operators will help. So today I will talk and hopefully, at least to some degree, simplify your Kubernetes life a little bit. And I will talk about operators. So first, I will discuss a little bit what is an operator and how can we develop one. Second, I will show you how you can find, deploy, and use an existing operators that are available for everyone. Thirdly, we will then develop our own small little operator with a small showcase that we have running in a real customer project we use. And then I will talk a bit about why when to use one, when not to use one, what do you have to keep in mind. All right. So, what's an operator? I prepared this little graphics because I think everyone knows kubectl. At least, hopefully, everyone knows in this room knows kubectl. And I think most people know that when you type in kubectl get pods, you talk to the Kubernetes API server, which is just a REST API as every other REST API is. It provides resources, it lists them, you can use you could use curl to do the same thing. It's just a more simple way to do this. The Kubernetes API server, if you talk to it, like kubectl get pods, what it does, it grabs the information from this call and sees, oh yeah, pods, I know this one. This is a resource I know because this is like a core Kubernetes resource, like deployment, services, pods, and so on. And it just grabs this information and says, all right, I know where to find pods. I grab them, list them up, send them back to the caller or to kubectl or whoever it was, and that's fine. There's no real operator magic happening here. But then there is the second part of the Kubernetes API, and that's custom resources. You can extend Kubernetes and the Kubernetes API using custom resources. You can register them against the Kubernetes API, and what happens then is the Kubernetes API server will say, well, I don't exactly know where I get this, because it's not a pod and it's not a deployment, but I know this guy knows, so just push him to the API extensions, and the API extension will then grab the object, the custom resource, and deliver you the same things as you are well known with pods and deployments. But there's nothing happening now. You have registered a Kubernetes custom resource. There's no real happening. There's no deployment that runs or anything. There's nothing happening because no one listens to those custom resources. And there is where operators come into play. Operators watch these custom resources and check if they change, if it was created, and anything. And they basically then handle the change. Whatever it is, it's code you write, you can develop, or you deploy. So it can be anything. It can be, as shown here, with a small create, delete, update core resource. You can like bundle them all up and have one custom resource that deploys your service, virtual service, deployment, and so on. But you could also deploy cloud resources. You could also calculate some stuff that you need for this custom resource. That's up to you. That's what the operator basically does. Sorry, I have a bit of a cough. How does this work? Well, you develop or you write your custom resource definition. That's the YAML on top. It follows a spec from the open API spec. You just write your YAML and say kubectl apply please this custom resource definition. Kubernetes then handles this over to the API server. The API server registers this as an API extension. It knows from now on I have this custom resource as an API I can use. Then you create your object, API version, as always, API version, kind, metadata, spec that you always use. You create your custom resource. And this resource then is basically stored in the Kubernetes knowledge sphere, in etcds and so on, where it is managed. And you can then later on say, hey, Kubernetes, please get me my resource back. And it will just ask, first it will ask the kube aggregation layer, which we will not discuss, it's a bit much for this talk. Then it asks, hey, is this a core resource? Do I know it? Is it a pod? Is it a deployment? No, it doesn't seem like it. So we will grab the API extension and just look there, and yeah, the API extension then knows, all right, this is a custom resource, I have this stored here, and delivers you back the same response as you would get with any object. I know all of you now think, but Corvin, you promised simplified Kubernetes. That's not simplified Kubernetes. That's a lot of bullshit and a lot of stuff on top of it. What the fuck are you talking about? And for that, I will show you two cases where you can use these operators. The first one is how we use an existing operator, how we can deploy it, and how we can use it. In this case, I will use the Azure Service Operator, which allows us to create cloud resources without leaving the Kubernetes. Yeah, without leaving Kubernetes as a tool. And the second one I will do or will discuss is how you can write your own operator and how you can deploy and bundle up your deployment information in one go and don't need to take care of so much information. For this, I will explain a bit more later on. All right, and I have to go to my laptop because the demo is, of course, on my laptop. So, we want to work with operators. We want to deploy them. We want to use them. How do we do this? First of all, you need to discover an operator, basically. You need to know, all right, I want, like, I work a lot with Azure resources, and we have the problem that all our developers run to our ops guy and say, here, can you please give me a storage account for my service? I need it. It's important. And you say, well, we could use the Azure Service Operator instead, so the developer knows when he needs a storage account and just creates it. To find operators, the best resource is the so-called Operator Hub. The Operator Hub is basically like the Docker Hub for container images. It's like the hub for operators, where you can find a lot of operators. I think it's around 300, yeah, around 300, not yet 300 operators that people in the community develop. And you can find basically everything. You can find like the Strimzy operator for Kafka if you want to have Kafka topics managed with this. Instead of using Kafka commands and so on, you can just deploy the Strimzy operator and have your Kafka running in your Kubernetes cluster if you want that. You can find Tekton. You can find, for example, Tekton operator, which makes installing Tekton on your cluster really easy. It just manages it and also allows you to automatically update the Tekton version and so on. And you can find, that's the one I want to show, for example, the Azure Service Operator. And as I said, this allows you to deploy cloud resources without leaving the Kubernetes ecosphere we know. And a lot of developers might be now familiar with, at least. They might see Terraform code or Pulumi code or so and see that and think, oh, that's infrastructure stuff I don't want to take care. But they see deployment YAMLs and think, yeah, well, I have to take care of it. This is mine. I know that. OK, I will do that. And maybe they see a resource group YAML and think, OK, I can do that because it's just a YAML. Thanks. I prepared a little bit for this, because to use this operator, you need, on the Azure cloud, you need a service principal that is allowed to deploy resources and so on. And I don't want to have the secrets openly public in a video recording. So I already created secret and set up the operator a little bit. For this, the explanation here is already present. You can just read it through and create a service principal that is allowed to create resources on your Kubernetes. And also, I have, ignore all the other 9 Kubernetes clusters. I have a cluster here that is, I have a Kubernetes cluster. It has 1 node and is really small because I just need it for the demo. And it runs also on AKS. To now deploy this operator, you have 2 options. you could go up here and click install, and you see this. Sorry. And you see this. Maybe I should take a sip of water. And this installation tutorial basically shows you how to go step by step to install the operator. It starts with operating something called the Operator Lifecycle Manager. And the Operator Lifecycle Manager, I already deployed that. Basically, what it does is it's itself an operator that registers some custom resources, like a subscription, to other operators that you can find in a catalog. And the catalog, in our case, is just the operator hub. You can set up different catalogs where you have a lot of operators maybe stored. And then the Operator Lifecycle Manager, OLM, just basically gives you the opportunity to deploy an operator with just a few lines of YAML or from the internet by just using the install instructions here with this. Operator install Azure service. I copy-pasted that YAML over so we can look at it. I hope you can see that. Yeah, it seems fine. Looks like this. It's a custom resource for specifically this operator that just is a subscription, and that means we subscribe to this operator on a channel, in this case stable. Whenever the operator on the stable channel changes, we get this update on our cluster. So we automatically have a lot less to take care of, because the Azure Service Operator will just auto-update for us whenever something changes there. For the stable version, at least. We can just apply this. And then we created the subscription. Of course, we didn't create it in the namespace ORM. We did create it in the operators namespace, where the secret is for the Azure operator that all the information has that it needs. Let's do the same. That's not the right one. Sorry. Yeah. Sub doesn't want to let me get the subscription for some reason, because I maybe typed something. Now, perfect. Yeah. Now we have the subscription for our service operator here, which comes from the operator hub catalog, which I just showed you with the around 300 operators in there from the channel stable. There are also other operators, other channels like beta channels where you can test out and so on. What this also creates is a so-called cluster service version. And this cluster service version is nothing else but the operator in one specific version on your cluster. This is needed because, as I said, you want to have like auto updates. And you see here, I have deployed the Azure Service Operator with version 1028631. And this would replace a cluster service version with the name Azure Service Operator V1027207, which I didn't have running because I didn't deploy that early or didn't deploy that version. But if I would have deployed it, it would automatically be upgraded to the newer version for me. And then, once the cluster service version is deployed, we also get the Azure Operator Controller Manager. So that's the real operator, the deployment for the operator. It runs as a pod, of course, and with with 2 containers running there. And this is just the real operator that handles all the interaction with Azure. Now I can say, yeah, I deployed it. Fancy, but we can, of course, easily, we can shortly show that it also works. I am logged into the Azure portal here, and if I check for a resource group with ContainerDays as a name or CDS as a name, I don't have one. Let's create one. I can apply the resource group file. This is really simple. It's just a resource group is just basically the name of the resource group, in which namespace should I deploy it, and for which location. Yeah, that's it. Then we should have now a resource group. At least we can check, do we have a resource group deployed in our cluster. And what you get here as an information is the provisioning status. Is it provisioned on Azure as a real resource? Let's check if it's in the portal. It might not be, because there is a little bit of delay in the portal. But here we have the resource group created without interacting with either the Azure CLI or anything. The same thing. We have nothing in the resource group, but we could, of course, apply a storage account, which is also just as the which is also just as the resource group a YAML. All of these YAMLs are described and have a documentation on the Azure Service Operator. I cannot show you all, of course. They have like the fields for what is it, a storage account? I want to name it like this. I want to have it in this resource group. Then which SKU it should use, which kind, access tier, and also it allows for private networking if you don't want to have it publicly available and all of this. Now we have created the storage account. Let's check if it's provisioned. Yep, seems to be provisioned. Check if it's in the portal as well, just to make sure. Nope, it's not, because the portal is sometimes a bit slow. And here we have the storage account without ever interacting with the Azure CLI or anything in the background. That's just the Azure operator does all of this. How do we connect to this storage account from an application we might want to deploy? The operator creates these secrets. And if we use a little crew plugin to show this secret, we just see here the connection endpoint, and there's also the keys for these connection endpoints that you need and to make the connection. So we can just mount the secret as we would always with configuration in our deployments in our application without ever touching anything. And it also is backed by or it can be backed by the CSI driver, so you can automatically create key vault secrets by that way. Haven't set that up, but it's possible. All right. And if we want to remove all of this and clean up, we can remove the resource group. And once this is gone, it will delete the custom resource. It will also delete the storage account, since the Azure operator knows, all right, the storage account, well, it didn't for now. It will at some point. No. It will delete this because the Azure operator knows, everything that is belonging to this resource group is just when I delete the resource group, remove everything. We don't need this anymore. And we could look here, but the Azure portal is quite slow with regards to deletion, so it might take up to, I had some runs where this took 5 minutes to delete from the portal view. Why I don't know. All right. So this, and also if you want to really make sure, okay, I tried out the Azure Service Operator, I can remove the subscription. I can remove the CSV. And then I can check, and the operator is gone. I have to clean up manually all the custom resource definitions and all the custom resources it creates. That's manual effort. Just check once, delete them. Done. Then it's really, really gone. All right. So now that you should at least know a little bit how we can work and find these operators, sorry, let's check how can we develop our own operator to make sure that to use the most of these concepts. And for this, there's a quite nice tool called the Operator SDK. I will not go too deep into it. I will just use it for one specific operator that replaces a lot in this scenario. This is a scenario we have at a customer. Basically, the idea is we have a service that automatically needs to, or dynamically needs to provision other services with specific metadata. And this data is stored in a file, and it just grabs basically on startup. The service grabs the file, you say, please grab this file. It grabs the file and then does magic and provides an API for this specific file in some way. Currently, the setup is like this. Someone, mainly some guy that decides what is of these files which are accessible currently and which are not, because they are not always all accessible, and sometimes they get new versions and so on. To get this, some guy decides, yeah, I want to deploy these files, and create something called a deployment request. Internally, deployment request. It's an object that we store in a database. And then we have a second service, that's the status manager, that just regularly queries this database, queries the state on Kubernetes, checks, yeah, that should be deployed, that is deployed, and calculates from this the actions it has to do, like delete those files from, or those deployments, create those deployments, and so on. And then to create all of this, it talks directly with the Kubernetes API server and just says, well, deploy me, create a deployment with this exact environment variables, with this metadata, with these limits, resources, and so on, requests, and so on. It directly talks to the API server. It allows for a lot more. It also deploys automatically like a virtual service for Istio and stuff like that, which is all fine, it all works. But the problem here is that the service we initially deploy is built by another supplier, another company. And when they say we need a new environment variable, we have to change our code, because we have to change the code where we say create this deployment with this environment variable. And usually you would try to avoid such scenarios, of course. Let's see if we can use an operator for this. And this is a really boiled down view of the whole thing. Basically, we still have someone who says, I want this file to be deployed. And he still has a UI, that's the admin part. He still has a UI where he clicks in, because he's not a guy who uses kubectl or has this installed or anything. He just uses a web UI, clicks in some buttons, and call it a day. This could then instead create a custom resource, which we have defined earlier, based upon a Helm values YAML. We create this custom resource, and instead of then, of course, we have that status operator, no longer a manager. That doesn't need to schedule regularly over some database or so. It just gets notifications whenever a new custom resource is created, and it then basically just does a Helm deploy, or Helm release, creates the release for this, and or updates or deletes the releases it needs. And this has the advantage that the Helm chart can be managed by the people who develop the service without us needing the status operator to touch it, because we just say, status operator, here are the Helm charts, take them, take this repository, and deploy whatever you find there when you get this custom resource. All right, let's see this in a really, really small demo, because I don't have that much time, to be honest. Let's see how we can easily do this. And there is a tool called the Operator SDK. The Operator SDK allows us to create operators based upon either, as here, a Helm chart, which you can import or which you can reference with a Helm repository and so on, or Go or Ansible code. We can use all these three, and they allow us to basically, in Go code, you can do everything, so they allow us to do everything with this operator and develop the code as we want. For the Helm thing, it's basically just deploy the Helm chart. The Operator SDK needs some commands, like the Operator SDK initialize, please initialize me the whole operator, then create an API, and that's basically the custom resource you create based upon the values YAML that is automatically created when you have a Helm chart. Either you have the Helm chart imported, or it will automatically create one for the Nginx Helm chart. That's just the Helm create demo. Then you can build the Docker image from that, push it to the Docker Hub in my case, and deploy this on your cluster. And then in the last line, there is a small sample how you could create the whole custom resource and deploy one in one go. I will just run this. It's here quite fast because I already ran this and have all the images in my local storage and in my local cache and everything. And there is some issue here, method not allowed. All right, That's demos as always. We just check which command it failed. I think it failed. Just check. This seems to cause some problems because I cannot really read the namespaces, unfortunately. And takes ages. Let's see if my Kubernetes cluster didn't break for some reason. Seems to be up and running. All right. It has this new namespace, CDS operator system. CDS operator is just the name of the operator I took. And let's see, it has the controller manager running. And I created a custom resource. The server could not find the requested resource. All right, that's weird. I have created a custom resource called ContainerDays that I should be able to deploy. Maybe if I just forcefully reapply this. Let's see. The deployment worked, but unfortunately not sure why this happened. Sorry, don't really know why currently this doesn't grab the correct, or why it doesn't grab the correct configuration and just deploys. I can just check if there's no pod. Sorry, but usually that worked. Assume it works and then hope that it really works. So that would be the way to create such a small operator to just have the Helm charts running. All right. Back to a more safe medium, not a live demo. Recap. When should you use this, when not? An operator is really powerful. You can do everything with it. It's just code you run in your cluster, and it can do anything with the custom resource. And especially if you use operators that are already present and developed by communities, you have to trust the operator. And that's maybe tricky, because you have to trust that the developers of this community don't break anything and that they behave like you would assume. And you have to give it a lot of trust in your infrastructure. For example, the Azure Service Operator requires a service principal that can create and also delete everything. So if you do a mistake and fuck up, then yeah, well, that's it. So the operator is powerful, and it can simplify a lot of deployments. It can simplify a lot of stuff with Kubernetes, but it also comes at the cost of A, more trust towards the operator, and B, operating the operator. The operator lifecycle manager already helps with that by auto-updating and so on, but it's not completely perfect. And this means that you have some work to do with the operator to operate the operator, if you can follow me. All right. And with that, I'm finished with slides. Any questions? Any?
Yes. There are some questions. I brought my phone with me.
All right.
Because we have the questions on Slido, and I have the admin view, so I see more questions. If you haven't, please take out your phone and vote for the questions you are most interested in while we start answering. We have one that is upvoted. Can I utilize operators also for non-CRUD operations like stopping a service, creating a snapshot, update resources, and get the service back online? Can I?
Yes, to some degree. You can do anything. It's just your code, whatever you want to do. It's just work if your service can support this behavior. If yes, sure.
Okay, so this is answered. Yeah, it appears. Which tool do you use to switch between namespaces?
It's a crew plugin for kubectl called KNS, and it integrates into fuzzy finding, FZF, and then this gives namespace changing.
Okay, what else do we have?
It's the Azure operator replacement for Terraform. Not fully. You cannot do anything with the Azure operator that you can do with Terraform. Setting up a Kubernetes cluster is not possible with the Azure operator, for now at least. It can create some resources, but it cannot create anything. So it's not a fully replacement. It's partially a replacement, maybe.
Okay, let's see. What else do we have? Do you know whether any other languages outside of Go are planned for the Operator SDK?
The Operator SDK works on a plugin principle. As you have seen, I specified a plugin Helm. The 3 plugins that come is Go, Ansible, and Helm. There are other plugins that are community-driven, not fully supported by the Operator SDK on its own, but you can use Java, Kotlin, anything in that direction also. So yeah, there are already other languages usable via the plugin concept.
Okay, what else do we have? Since the operators are needing special permissions, how are those handled and managed such that to avoid misusage?
That's up to you, I guess. It's tricky to answer that question. It needs specific, of course, permissions to, for example, deploy resources, because this can cost money, and then, of course, you need specific permissions and so on. And it's up to you to say, well, who can delete resources on my cluster? How do I interact with my cluster? That's up to the, let's say, cluster manager. I'm not sure how you would name that or how you name this in your organization and so on, but that's up to you. The operator cannot really do that.
Okay. Could you show briefly the source of your container? What steps need to be implemented?
Could you show briefly the source of your container? Well, I can show the source, but I think mainly there is a Docker file, as you can see. And that's it. The operator framework, or the operator SDK itself, behind the scene uses KubeBuilder, which is a library to build operators. It's not really that much. You just say, here's the Helm charts, and then all of it is handled by the framework, in that case.
Okay. Would you use operator on one cluster to provision a cluster elsewhere, almost like cross-plane? Is it better for internal cluster operations?
I haven't used that. I'm sure the Azure operator cannot really use that because it cannot create Kubernetes clusters for now. There are other operators for other clouds that can do that, but I haven't used them, unfortunately.
Okay, there are more and more questions coming in. I really love that, and I love that you vote them and helping me to find out what is most important. Maybe we don't get to answer everything. So in case we cannot answer everything, where are you on this conference? Where's your booth?
Right, I forgot that, and I'm pretty sure some group around this area asked that question. I'm not 100% sure. Novatec has a booth at this conference. We are, if you go out all the way left where you get your conference t-shirt,
I think it's right.
It's right?
It's right.
Oh, no, I messed up.
I think
all the way right? Not sure. You go to where you get your conference t-shirt. There we have a booth. You can come up to me, ask me about all of this. You can discuss anything, talk to me, talk to other colleagues that are here at the conference. And you can also participate in a giveaway, I think.
Okay.
It seems I'm right. You can participate in a giveaway.
Someone is nodding. Did you look to your authorities?
No, not at all. I just knew that by heart, of course.
Let's do some more questions. How can you test operators during development best?
Usually, what we did a lot is we deploy them on a testing environment cluster. We just have we have a cluster that is not production, and we can just deploy on them. And we can also, you can use tools like Kind or so to create clusters on your local machine and deploy them there and test them there.
Someone asks if you can take a look at the example at your booth. I think we answered that. You can.
Yeah, of course.
Of course. Will the K8 API become the Unified Cloud Vendors API?
I think to some degree yes, to some degree no. To some degree, yes, the standard stuff will at some point maybe merge more and more into Kubernetes. And a lot of cloud vendors try to use Kubernetes as their platform and use this as a setup and offer this as a service. Not everything, because of course cloud vendors try to sell their product, so they try to have unique selling points, and those unique selling points might not merge into Kubernetes, because then it wouldn't be a unique selling point anymore.
Okay, so we're at the end of the Q&A.